Sea ice is a source of danger for offshore platforms and ships. One particular source of danger is icebergs. Originating from Svalbard, Franz Josef Land and other ice-covered archipelagos, the icebergs occurring in the Arctic waters represent gigantic fragments of glaciers. The largest ones break off Greenland. Unlike earlier, when icebergs tended to stay within the waters of Greenland without drifting too far eastwards, these days the ongoing climate change is causing them to drift into the Barents Sea, the latter known as the ice-free sector of the Arctic Basin. The offshore structures can receive grave damage from collision with a group or one vast iceberg. Not only can the collision cause mechanical damage, it can lead to oil spills and serious environmental aftermath. Started in 2018 and funded by the EU-Russia cross-border cooperation program Kolarctic, Ice Operations is tasked with generating the solutions to reduce the operational risks in the Barents Sea. The project team consists of members from across the Barents region: Russia, Finland, Norway and Sweden. For this reason, the project chose to explore the Arctic sea ice using an integrated approach that encompasses the physical properties of sea ice, SAR image interpretation, historical data for the Arctic sea ice, as well as advanced computational methods and algorithms. A study as multifaceted as this is expected to provide an accurate description of the impact the sea ice may have on offshore structures and the scale of economic risks. In place of the reports covering the Barents ice conditions prepared by experts from NARFU, the SAR images have been verified against the actual ice conditions as observed by the project team from NARFU Arctic Floating University 2019. While on-site observations can produce a greater bulk of physical data necessary for further processing and interpretation, the field studies target to estimate the thickness, age and structure of the sea ice, as well as the direction of its drift. The analysis made use of cryogenic labs and mobile field laboratories. Since 2020, the project team at NARFU have been obtaining images from Sentinel-1 satellites to analyze the topographic features of the target area using Sentinel application platform. In parallel, the scientists at Finnish Meteorological Institute are working to develop algorithms for identifying sea ice hummocks based on high-resolution SAR images. Once in place, these algorithms will make it possible to map and keep statistical record of the emerging ice hummocks. In 2020, the project has produced its first sea ice modeling results, based on multi-criteria analysis that have been used for economic risk assessment purposes. The forecast of the ice situation in the Pechora Sea relied on fuzzy logic. The study also covered the northern and the western sectors of the Barents Sea. The project team at Luleå University of Technology are testing the physical properties of different types of ice and evaluating the parameters of ice structure interaction. A number of simplified models for calculating sea ice impact have been developed by Sintef Narvik. These models take due consideration of the type of ice and its dynamic performance. The project continues its activities. Year 2021 will see the team going on a number of expeditions for the final analysis of data and further development of the ice structure interaction model. One more potential source of accidents and oil spills is ship-to-ship transfer and marine carriages. The research-based deliverables of Ice Ops are expected to enhance the marine and environmental safety. The final results will be presented at international discussion venues. Work is in process to design a dedicated international educational course. With intellectual and infrastructure resources available to scientists in Russia, Norway, Finland and Sweden, Ice Operations will have as its final deliverable the up-to-date database on ice loads likely to be experienced in the northern seas. Once in place, this database will be a helpful tool for more effective risk-based decision-making concerning the Arctic development and ways to make human presence in the Arctic safer.